All right. So, it's July 25th. Everyone's in the loop. Telescopes worldwide are buzzing about the same thing. They've spotted an object, named it 3I Atlas, the third interstellar visitor after that cigar, Oumuamua and Comet Borisov. But here's the fundamental difference. Those other two flew by, gave us a wave, and left. This one, it's not leaving. It's coming to us. The sun's gravity has snared it. And that changes everything. Absolutely everything. For the first time in human history, we have a chance not just to watch a visitor from another star system through a telescope, but to literally reach out and touch it, to study it up close as the sun starts to toast it. This is a unique opportunity, possibly the only one in our lifetime. So the question isn't, is this interesting? The question is, what are we going to do about it? Let's stick to the facts from a physics standpoint. Initial analysis. A comet. 11 kilometers in diameter, ice, dust, the standard stuff. But the speed, 210,000 kilometers per hour, that's insane. To intercept it, we need a delta V of 24 kilometers per second. 24. The people who build rockets understand just how absurd that number is. The Dawn mission, which went to Ceres, took years and a ton of energy to achieve far less. And we don't have years. We might have months. Every day we wait is a lost opportunity. Forever. But that's not all. There's an anomaly. Its brightness. It's pulsating. Not like a regular comet just venting gas. There's some weird, irregular pattern to it. Most scientists will say, oh, it's just some geological process we don't understand yet. And they might be right. But what if they're not? What if it's not just geology? We have to consider every possibility. It could be anything. From a natural phenomenon that will flip our understanding of comets on its head to something much more interesting. The irony is, the Atlas system that found it was built to protect Earth, to find killer asteroids. And instead of a threat, it found the greatest opportunity in the history of science. This isn't a problem to be solved. It's an invitation to be accepted. Of course, the arguments are about to start. Some will scream, let's just collect data on its chemical composition. That's important, sure. But that's looking through a microscope when the entire universe is in front of you. Others are asking the right questions. What if we find complex organic molecules? The very same ones that life sparked from here. That would mean life isn't our unique little trick. It might be a fundamental principle of the galaxy. So here's our plan. We're not going to sit around and argue. We're going to act. This task is on the edge of what's possible. But that's exactly why we built SpaceX. Intercepting 3I Atlas isn't just a science mission. It's a test of maturity for all of humanity. It's our chance to ask the universe a question, directly, and we have to be there to hear the answer. This dilemma isn't just scientific, it's existential. For centuries, humanity has wrestled with the question of its uniqueness in the universe. Every new discovery expands our view, but also confronts us with new questions. 3I Atlas, with its precise trajectory and unstable glow, is a kind of cosmic mirror, reflecting a central question. Are we ready to admit that we know almost nothing about the cosmos around us? Meanwhile, the clock is ticking. 3I Atlas is expected to reach its perihelion, its closest point to the Sun, in October 2025, at a distance of about 1.3 astronomical units. When that happens, its activity will peak, and it will spew gas and dust in quantities that could turn every second of observation into a treasure trove of unprecedented information. But soon after, it will begin its journey back, disappearing once again into the interstellar darkness. This opportunity is as rare as it is fleeting. In the midst of this scientific race, a more subtle but no less unsettling question arises. Is the behavior of 3I Atlas merely the result of natural forces? Or is there some unseen order guiding its movement? The past has taught us to be cautious. Oumuamua, for example, also showed acceleration that couldn't be explained by traditional phenomena. Harvard astrophysicist Avi Loeb even suggested it could be a probe sent by a distant civilization. The idea was met with skepticism at the time, but now, with Atlas, those doubts have returned with a vengeance. Whatever the case, the visitor is here, a piece of a galactic neighborhood we've never seen, carrying in its very structure the keys to a cosmic history that unfolded long before we existed. For the first time, humanity has the chance to watch an interstellar messenger in full swing, breathing in the sun's warmth and reacting to our system in ways that defy our predictions. The viewer following this story needs to understand. 3i Atlas is not just another bright dot in the sky. It's a symbolic portal, a key that could unlock new understandings of the origin of life, the nature of the cosmos, and our place in it. To ignore it would be to miss an unrepeatable opportunity. But to embrace it requires courage, technology, and above all, humility in the face of the vastness it represents. The silence of space is never truly silent. Every celestial body, every particle, every wave of radiation carries encrypted messages about the history of the universe. 3i Atlas is more than just a visitor. It's a message in motion. And a simple yet crushing question arises. Will we manage to decipher it before it vanishes forever? And this is where the first part of this narrative ends, because hidden beneath the icy surface of 3i Atlas is something that has not yet been discovered. Something that could change our understanding not only of space, but of ourselves. But what makes 3i Atlas so unsettling isn't just its origin or its speed, but the possibility that its trajectory is no cosmic accident, but part of a grander design. When the news about 3i Atlas broke, it wasn't just scientists who felt its impact. All of society, directly or indirectly, was touched by this discovery. Newspaper headlines screamed, TV shows buzzed with debates, and social media was a storm of theories, questions, and even jokes. But beneath the initial wave of curiosity lay something deeper, a sense that this interstellar object was not just another chunk of ice crossing the sky, but a mirror of our times, reflecting our fears, ambitions, and contradictions. Applied science felt the pressure immediately. Astrophysics labs and aerospace engineering centers began to reshuffle their priorities. NASA, ESA, and other space agencies recognized the strategic dilemma. How do you respond to an opportunity that won't come again for centuries? It's the same pressure a doctor feels when faced with a patient showing an extremely rare symptom. To ignore it is to miss the chance to understand something vital. To act requires effort, risk, and a complete reorganization of resources. This dilemma wasn't confined to technical circles. It resonated in the collective imagination. Modern people, used to dealing with immediate problems, inflation, elections, climate change, regional wars, were suddenly confronted with a question from far away, from beyond Earth. What do you do with a visitor from a distant corner of the galaxy, carrying clues in its structure about regions of the universe we've never explored? For many, it triggered a sense of helplessness. In the 1990s, when the Hubble Space Telescope unveiled the ultra-deep field image, showing thousands of galaxies in a tiny patch of sky, it was already clear that Earth held no privileged position. But seeing an object from another star crossing our cosmic backyard is different. It's as if a stranger knocked on our door, reminding us that we are not just distant observers, but also targets and participants in a living universe. In daily life, this translated into conversations that seem trivial, but are historically significant. Imagine a science teacher trying to explain to their students why this comet didn't come from the Kuiper Belt or the Oort cloud, but from a place we can't even pinpoint. or a young enthusiast spending a night sky-gazing, trying to imagine the millions of years-long journey that brought Atlas to us. It was even felt in the financial news. Stocks of space tech companies began to fluctuate, pricing in the possibility of emergency contracts for intercept missions. Then there's the emotional level, which few admit to publicly. People like to feel in control. They like to believe in the predictability of the sky and the reliability of the Earth. But the arrival of 3i Atlas shatters that perception. It reminds us that we live in a dynamic cosmos, where giant forces are indifferent to our existence. This realization sparks two opposing reactions. On one hand, fear. On the other, an irresistible fascination. Because it is in this discomfort that important questions and great revolutions are born. History shows this is nothing new. For example, in 1910, when Halley's Comet passed by Earth again, millions of people bought gas masks and doomsday pills, convinced that passing through its poisonous tail would mean humanity's extinction. Irrational fear spread like wildfire. Today in 2025, we live in a much broader information age, but the emotional patterns remain the same. The difference is that this time, the object didn't come from our backyard, but from outside, from a space where our theories are still fragile. From a scientific standpoint, this anxiety is a source of, well, anxiety. The international community is rallying around ground-based telescopes and space probes, studying every detail of 3i Atlas. Every change in its luminosity is recorded, every calculation of its orbit refined. But deep down, a question lurks. What are we really trying to prove? Is it just scientific curiosity or a hidden desire to find something that confirms our intuition that we are not alone? This tension also affects human behavior on a micro level. Imagine an average citizen with no scientific background who, upon hearing about an interstellar object, immediately feels a mixed sense of awe and insignificance. It's like seeing the ocean for the first time. Its vastness doesn't provide answers. It only amplifies your own smallness in the face of immensity. For some, this breeds humility. For others, a desperate need to regain control by creating simplistic explanations or conspiracy theories that spread with viral speed. Social media, as always, amplified this duality. On one hand, there was an explosion of genuine curiosity. Educational channels and astronomy forums racked up millions of views. On the other hand, distorted narratives emerged, talking about alien signals or threats of an imminent collision. This dichotomy reflects a fundamental aspect of our time. Science works patiently and with data, but society demands quick answers, immediate certainty, stories that either soothe or terrify. In this sense, 3i Atlas is not just an astronomical phenomenon, but a social experiment on a global scale. And this is where it gets most intriguing. Atlas is not just a scientific object, but a catalyst for the collective imagination. In universities, podcasts, classrooms, and even bars, it stands as a symbol of what we still don't understand. It challenges our haste, our short-sightedness, our tendency to think we already know enough. The interstellar visitor forces us to look up and admit that, in many ways, we are still flying blind. However, this discomfort could be transformative. Great discoveries are always born from the collision of the unknown with what we think we know. It happened when Copernicus argued that Earth was not the center of the universe. It happened when Darwin proved that life on Earth was not created in its present form, but evolved. Now, facing 3i Atlas, we are experiencing a similar shock. The realization that life may not be an isolated accident, but part of a grander story, written on a cosmic scale. This reflection touches us at our very core. Everyone who hears about 3i Atlas wonders, even for a few seconds, about their place in the universe. At a time when we are consumed by immediate worries, bills, deadlines, crises, comes a crushing reminder. We are part of a vast cosmos, and our planet is just a speck floating in an endless ocean. This awareness can be paralyzing, but it can also be liberating. That's why following this story is more than just watching a science report. It's about being part of a decisive moment for humanity. Because every piece of data collected from 3i Atlas tells us not only about the comet, but about ourselves. Our ability to learn, to face the unknown, and to admit that we are not the masters of the universe. And here, before we move on, it feels right to extend a sincere invitation to you. If you feel that same unease, if this story touches something you also feel deep down, please subscribe to the channel and like this video. It's not just a digital gesture. It's a way to stay connected to this search for answers that belong to all of us. This journey isn't over, and every update, every discovery, could change how we see our own lives. 3i Atlas is a rock of ice and dust, but it is also a metaphor. It proves that the universe is not static, but dynamic, unpredictable, and above all, alive. And when we look at this interstellar visitor, we don't just see it. We see ourselves, projecting onto it our fears, hopes, and limitations. However, the main event is yet to be revealed, because Atlas, beyond being a scientific challenge or a philosophical reflection, might be carrying a disturbing signal, something that doesn't fit the natural behavior of a comet, a clue that could completely change the course of our interpretation. And at this point, the narrative begins to take an unsettling turn. What scientists are about to reveal about the strange behavior of 3i Atlas could upend everything we thought we knew about cosmic visitors. As 3i Atlas hurtles toward the sun, telescopes on the ground and in space are focusing their electronic eyes on its every flicker. The scientific community knows it's facing an unprecedented event, watching a still active interstellar object before it disappears forever. What could have been another catalog entry has turned into a race for data. Every spectrum of light captured, every brightness reading, could hold information that radically alters our current understanding of astronomy and astrobiology. Initial spectroscopic analysis points to a relatively common composition: water ice, dust, and silicate minerals. In theory, this makes it similar to comets from our own solar system. But at the same time, other data is starting to baffle researchers. The brightness of Atlas doesn't follow the expected pattern for a comet approaching the sun. Instead of a predictable curve of activity, there are sharp fluctuations, more like pulses than a continuous outgassing. What does this mean? Are we looking at an unusual chemical reaction, an unknown internal dynamic, or a previously unforeseen interaction with the solar wind? These questions are not trivial. Each hypothesis opens new paths and creates new dilemmas. If it's a different chemical process, it suggests that the conditions for comet formation exist in regions of the galaxy we didn't even know existed. If it's an internal reaction, we might be witnessing some kind of unknown interstellar geology. If it's an interaction with the solar environment, it means even our model of the sun's influence on celestial bodies might be incomplete. How many of our current certainties are really just temporary approximations? How much courage does science have to reformulate models that seemed unshakable in the face of such a persistent anomaly? Another point that defies traditional explanation is the acceleration of 3i Atlas. The object is showing slight changes in speed that don't fit the pattern predicted by solar gravity and the outgassing effect alone, where sublimating ice acts like a low-thrust engine. This anomaly was already seen in 2017 with Oumuamua, which sparked a fierce debate about whether we were dealing with an unusual natural object or something more complex. Harvard astrophysicist Avi Loeb proposed the hypothesis that it could be an alien probe built by an advanced civilization. The community reacted with skepticism, but no one could provide a definitive explanation. Now with Atlas, the debate is back. The question is not just whether we're dealing with technology or a natural phenomenon, but what this says about our own limitations. Is the tendency to reject bolder hypotheses a defense against the discomfort of re-evaluating our place in the cosmos? Or is it just the methodological caution needed to avoid jumping to conclusions? Meanwhile, some research groups are using computer simulations to test different scenarios. 3D models show that the trajectory of 3I Atlas is so precise that it approaches what engineers would call an optimized path. There are no chaotic deviations, no random tumbles. The body remains firmly on its calculated course, almost as if following a geometric plan. This in itself proves nothing, but it creates a quiet sense of unease. Is it just a coincidence, or a pattern we haven't yet deciphered? We're trained to believe the universe is inherently random. But what if that randomness is partly just a product of our instrument's low resolution? While some focus on the physical aspects, others are looking at the astrobiological dimension. Atlas might contain organic compounds that, if analyzed, could help us understand how life might have arisen on Earth. This line of inquiry is based on the hypothesis known as panspermia, the idea that the building blocks of life, like amino acids and nucleotides, could have traveled through space on comets and meteorites, seeding different worlds. So far, panspermia is considered a hypothesis, but several experiments have already shown that complex molecules can survive long interstellar journeys. If organic material is found in 3I Atlas, it wouldn't be definitive proof of panspermia, but it would be a strong argument in its favor. We would have evidence that the fundamental components of life are not unique to Earth, but are part of a common cosmic chemistry. How would that affect our notion of our own singularity? How much would it change our religious, philosophical, and cultural perceptions of being itself? Another critical aspect is the technological challenge. Several space agencies are already discussing the practical difficulties of intercepting Atlas. A flight from Earth would require almost impossible amounts of energy, but as recent calculations have shown, an intercept from Mars would significantly reduce the effort needed. This possibility is not just an orbital curiosity, it's a game changer. For the first time, Mars is being considered not just as an object of scientific study, but as a strategic platform to reach other cosmic visitors. How ready are we to reconfigure space exploration based on this new paradigm? Could 3I Atlas be the push humanity needs to finally establish an operational presence on Mars? These debates bleed into social and political realms. In an era of geopolitical disputes, the idea of a joint international mission to intercept Atlas seems both logical and unlikely. Cooperation would be necessary, but the scientific and political prestige that a successful mission would bring could spark fierce rivalry. History shows that major technological breakthroughs have almost always occurred in a context of competition, from the Cold War space race to the recent battle for commercial launches between SpaceX, Blue Origin, and government agencies. 3I Atlas fits the same script, an object that belongs to no one, yet is coveted by all. Will the universe force us to confront our internal divisions again before allowing us to understand what lies beyond them? From a philosophical perspective, the situation is even more unsettling. The very fact that we are debating the origin of an interstellar body shows how our minds search for patterns even in what might be completely natural. This is an anthropocentric tendency, not a flaw, but a feature. Every time we look at the cosmos, we project our own questions onto it: origin, purpose, destiny. In this sense, Atlas is more than just ice and dust. It's a stage for human dilemmas about control and meaninglessness. Isn't this the secret function of every interstellar visitor? To force us to acknowledge our insignificance, but also our capacity to expand our boundaries? As October approaches and Atlas reaches perihelion, the pressure mounts. Every new measurement makes headlines. Every deviation fuels debate. The public watches, partly fascinated, partly indifferent, unaware that this might be one of the most important moments in modern scientific history. Science is unfolding in plain sight, But the significance of what's at stake has not yet sunk in. What's at stake is not just the analysis of a comet, but the chance to redefine humanity's relationship with the cosmos. We are facing an alien that might give us answers but could also multiply our questions. Ultimately, what will matter is not the object itself, but how we choose to handle it, as a scientific community, as a society, and as a species. 3i Atlas continues its journey, but now the question is unavoidable. Can we turn this opportunity into real knowledge, or will we let the visitor get lost in the darkness, taking with it answers we may never have another chance to get? 3i Atlas, with its calculated trajectory and irregular glow, is not the first cosmic visitor to challenge us. The difference is that this time, we can't plead ignorance. The history of astronomy is full of signals that were underestimated, misinterpreted, or simply ignored because they didn't fit our models of the world. In this sense, the past is not just a memory, it's a warning about the opportunities we've already missed. A prime example is the case of Oumuamua, discovered in 2017 by the Pan-STARRS telescope in Hawaii. It was the first confirmed interstellar object across the solar system. Its elongated shape, like a cigar or a flat pancake, puzzled scientists. To make matters worse, it showed acceleration that couldn't be explained by gravity or the jets typical of comets. The scientific community split into two camps. Some tried to fit it into traditional models, while others, led by Avi Loeb, suggested it could be an interstellar probe. The hypothesis was ridiculed by most, but to this day, there is no consensus on its true nature. The Oumuamua affair became an open wound. A visitor came, left mysterious clues, and departed, without us having the courage to face it head-on. How much valuable data was lost then? How many researchers stayed silent to avoid challenging the scientific status quo? 2 years later, in 2019, came comet Borisov, also interstellar, but with more familiar characteristics: a dust-rich nucleus, a pronounced tail, and a composition similar to local comets. Borisov reassured the skeptics, who used it as an argument for the normality of the phenomenon. However, few paid attention to a crucial detail. Its chemical activity revealed anomalous concentrations of carbon monoxide, significantly higher than those in solar system comets. This finding was noted in specialized papers but rarely made headlines. Pop culture preferred to frame Borisov as the visitor that proved interstellar objects are just normal comets. But the truth is, even normal comets hide variations we can't explain. Why is the simplest narrative always chosen, even when the numbers point to something more uncomfortable? These cases show how science and the media move in different directions. While scientific papers express doubt, headlines rush to offer certainty. The result is a mass culture that thinks it's informed but is actually consuming diluted and sometimes misleading versions. With 3i Atlas, the risk of repeating this pattern is huge. The irregularity of its acceleration is already documented, but in many media outlets, it's still presented as slight deviations. Slight compared to what? Deviations from which model? This softening of terms hides the seriousness of the phenomenon and weakens the sense of urgency. Throughout history, this pattern repeats. In 1908, the Tunguska event in Siberia devastated 2,000 square kilometers of forest. Popular theories range from an asteroid to an alien spacecraft. For decades, research was inconclusive until much later when scientists settled on the hypothesis of a cosmic body exploding in the atmosphere. But the initial reports, scattered and discredited, delayed the understanding of the event. In pop culture, the Tunguska event is still considered an absolute mystery, even though science has made significant progress in explaining it. What does this tell us? That there is always a gap between what is recorded, what is studied, and what is understood. Is 3i Atlas destined to fall into the same gap, becoming a misunderstood legend instead of being properly studied? Another little-known case is the asteroid Apophis, discovered in 2004. Initially, the probability of a collision with Earth in 2029 was estimated at 2%, causing a media frenzy. When new calculations significantly reduced the risk, the story was forgotten. However, that episode left an overlooked lesson: the fragility of our monitoring systems. An object just a few hundred meters in size was enough to put the global scientific community on high alert. Today, with Atlas, we're talking about a visitor that not only passes by, but brings with it the possibility of discovering unknown regions of the galaxy. How many times do we need to be surprised before we admit that we still know very little about what crosses our path? The statistics support this concern. NASA estimates that 60% of asteroids over 140 meters in diameter have not yet been cataloged. This means that at any moment, we could be caught off guard by an object with enough energy to wipe out entire continents. 3I Atlas, at 11 kilometers in diameter, is not on a collision course, but its very passage shows how dependent we are on luck and the patchy vigilance of our detection systems. The irony: we built telescopes to track threats, and one of them found something that isn't a direct threat, but rather a reason to reflect on our vulnerability. This vulnerability is not just physical, but intellectual. When a phenomenon doesn't fit a model, there's a tendency to interpret it in any way possible, even if it means distorting the data. How many technical reports have been shelved for not matching predictions? How many anomalous results have been dismissed as instrumental errors before being thoroughly investigated? The universe does not obey our expectations. It is our expectations that must learn to obey the universe. Think about how many discoveries could have been made if we had paid attention to the exceptions instead of ignoring them. How many advances were delayed because we preferred the safety of consensus over the courage of exploring the unexplained? Atlas carries this historical weight. It is not just a moving object. It's a chance to avoid repeating the mistakes of the past. If we ignore its anomalies in favor of hasty explanations, we will turn it into another missed opportunity. If, instead, we embrace the complexity of its signals, we could learn more than from any other interstellar visitor observed to date. This reflection brings us to a strategic question. What is the cost of missing such an opportunity? Are we willing to risk leaving it unanswered, knowing that the next interstellar visitor might not appear for centuries? This is not just a scientific dilemma, but a civilizational one. We face a choice: continue the historical trend of softening the unknown until it fits our comfort zone, or accept the challenge that the cosmos, by definition, is bigger than our ideas. Atlas, unlike the phenomena of the past, is still here, within reach of our instruments. The window is open, but the most unsettling question is yet to come. What will we learn when we finally manage to decipher the signals that Atlas has been persistently sending, signals that we have so far been unable to interpret in their entirety? 3I Atlas streaks across the heavens as an unsettling reminder. The universe doesn't wait for us. It follows its own trajectory, indifferent to our doubts, theories, and hopes. And in this silent movement, it forces us to face a dilemma that goes far beyond science. To ignore it is to repeat a history of missed opportunities, underestimated data, and anomalies dismissed for the sake of comfort. To understand it, on the other hand, means confronting the chaos it carries, the probability that our models are incomplete, our certainties fragile, and our self-perception distorted. The consequences of each choice are different, but both are profound. By closing our eyes, we will preserve the illusion that we know enough about the cosmos. We will continue to teach children that comets are just chunks of ice and dust, forgetting that some of them carry chemical variations that don't fit in any textbook. We will continue to believe that Earth is somehow the main stage, when in reality, it's just a brief stop in a theater too vast to control. This decision preserves tranquility, but it condemns our species to intellectual stagnation. On the other hand, If we embrace the discomfort of considering Atlas in all its complexity, we will have to revise not only our science, but also the way we understand ourselves. Acknowledging the existence of forces and phenomena beyond our immediate comprehension puts us on a path of radical humility. Science becomes stronger when it has to abandon old structures, but society, too, is forced to rethink itself. What does it mean to be human in a universe where life might be common, where interstellar visitors travel our cosmic spaces, carrying information we barely know how to interpret? The truth is, there is no escaping this confrontation. Atlas is not just a physical object, it's a maturity test for our civilization. Its anomalous acceleration, its irregular brightness, its precise trajectory. These are not just technical details, but symbolic elements. They remind us that reality is bigger than anything we can grasp. The universe is sending us signs. The problem isn't a lack of data, but our difficulty in accepting it when it disrupts our mental comfort zone. At this point, the reflection must become personal. How many times have we ignored signs in our own lives because they contradicted what we thought we knew? How many individual and collective opportunities have been lost because we preferred the safety of a flawed model over the courage to face complexity? Atlas, in its silent journey, is also a mirror of our daily choices. The question is not just scientific, it's personal. What do you do when something bigger than yourself challenges your logic? This discomfort is fruitful. All revolutions in thought have been born from the courage to confront what is uncomfortable. Copernicus challenged a centuries-old tradition by declaring, "We were not the center of the universe." Darwin was criticized for shaking the established view of life. Today, 3i Atlas demands the same from us, to admit that the order we impose on the world is only partial. If we lack the courage, we will remain trapped in the past. If we do it, we will open doors that will change not only science, but human consciousness itself. This is where the question becomes civilizational. What does it mean to lose an alien visitor? It's not just about losing scientific data, but about losing the chance to inaugurate a new era of human thought. When this object disappears, we might not have another one so accessible for centuries. What will we leave for future generations? The memory that we had a chance and we backed down, or the legacy that we seized the moment to expand our shared horizons? Time is running out. October 2025 is approaching, and with it, the perihelion of Atlas. As scientists refine their calculations, as instruments are aimed at the visitor, one question remains. Are we ready for what will be revealed? Not just technically, but existentially? History shows that we often are not, but it also shows that even in discomfort, we grow. The narrative now closes around an inevitable choice, to ignore or to understand. Ignoring preserves a world, but it's a world of ignorance. Understanding brings anxiety, but also growth. This is what Atlas is about. Not just ice and dust, but how we react to what is bigger than us. And here, in light of the situation, I extend a direct invitation to you, who have followed me this far. If this topic has awakened in you the same unease that drives scientists, if the discomfort of these questions has resonated with you, subscribe to the channel, like this video, and leave your comment, because this is how we sustain the search, share questions, amplify voices, and build a community that is not afraid to seek information. 3i Atlas will leave, and with it, perhaps, the chance to learn something essential about the cosmos and about ourselves. But while it crosses our sky, we still have the opportunity to choose. What path will we take between the tranquility of illusion and the courage of uncertainty? We will choose. Atlas is just a traveler, but how we see it will determine whether we are merely spectators of the universe or the protagonists of our own cosmic consciousness.